Hello, and welcome to this lesson on Pythagorean Theorem word problems. So we're going to be talking a lot about different ways and applications of the Pythagorean Theorem. So in the previous lesson, pretty much everything I gave you was just a right triangle, and we said find a missing side. It's going to get a bit more complex in this lesson. The essential question says, how do I use the Pythagorean Theorem to solve problems in both 2 and 3 dimensions? Did you know that the Great Pyramid of Giza in Egypt is about 480 feet tall, and each side of its square base is 755 feet long? So you could actually use the Pythagorean Theorem to find out how far you would go if you wanted to climb right up the side of the pyramid. So here's like a little picture. So it's about 455 feet tall, and each side of the base is that long. We're going to actually do this problem later on in the lesson, so let's get to it. Vocabulary, the Pythagorean Theorem, we've already had this word. So we know that a squared plus b squared equals c squared is the formula we use. We know that the a and the b are the two short sides. And we know the c is the hypotenuse, the longest side. So let's do it. It says Jose is going for a run. He runs due west for 4 miles, then turns south and runs for another 8 miles. How far is Jose from his starting place? The answer here is not 12. It's not asking the distance he traveled. It's asking how far is he. So here is Jose. Beautiful little dot. He runs 4 miles west. Now, if you don't remember which way west is, that's not really a big deal as long as you label. I mean, if you made a dot and you went this way 4, it's all going to be the same. But for your reference, never eat sour watermelons, or never eat soggy waffles is a nice acronym a lot of people use. All right, so Jose runs 4 miles west. Then he turns south and runs for another 8 miles. How far is he from his starting place? So he is right here now. Well, the distance from where he is to his end goal is this straight line connecting these 2 points. So we want to know, boom, 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 how far away he is. And because he ran straight west and straight south, that makes a right angle. So we can use the Pythagorean Theorem to solve and figure out how far he is from his starting place. Things I know. I know that the hypotenuse, whoa, that is a big highlighter. Let's just slow that down. I know that the hypotenuse is that x. That is my longest side. And so then the 8 and the 4 are my 2 legs. When I simplify here, I'm going to get 64 plus 16 equals x squared. That's 80 equals x squared. And when I solve this, I'm going to square root both sides, and we get, I don't know, whatever the square root of 80 is. It's almost 9. 8.94. And I should probably put a unit in here. So let's move some stuff. 8.94, was it miles? Yeah. Too much. All right, so I can put that back. X equals 8.94. So his distance he traveled was 8.94 miles. Okay, letter B. This one's for you already. A 25-foot ladder is leaning against a wall. If the base of the ladder is 7 feet from the wall, how high up the wall does the ladder reach? What I want you to do is I want you to actually pause the video and draw the picture first. Then hit play, because I want to make sure you have every piece of the picture labeled properly, because if you don't, you're going to make a mistake, okay? So go ahead and draw the picture right now. All right, so there's my wall, and here is my ladder. Okay, so I've got a ladder leaning against a wall. It says it is a 25-foot ladder, so the ladder piece is 25 feet. If the base of the ladder, that's the bottom, if the base of the ladder is 7 feet from the wall, that's this side, how high up the wall does the ladder reach? We don't know this height. So that's how our picture should look. If yours doesn't look like that, you might want to fix it. And if yours does, if you could please pause the video again and finish solving the problem, and then we'll get back together when you're done. All right, so a squared plus b squared equals c squared. My hypotenuse is the 25. That's my longest side. That means the 7 and the x are the a and the b. 49 plus x squared equals 625. I just know those numbers in my head. When I subtract 49 on both sides, x squared equals, I don't know, 625 minus 49 is 576. To solve this equation now, we're going to square root both sides to make this x squared become just plain old x. And when I square root 576, we get 24. So the height reaches up 24 feet is our final answer. So hopefully that wasn't too bad. This problem is a problem you're going to see a decent bit because, well, first off, it's hard. And it's a very common Pythagorean theorem problem because it's hard. It involves a lot of problem solving. And that's kind of the skill that we want mathematicians to have. They want to be able to solve problems. So it says here, a room is 8 feet tall, 12 feet wide, and 15 feet long. And you can see those values labeled. If a bee were to fly from the bottom corner of the room straight to the opposite diagonal corner at the top, so from this bottom corner to this top corner, what distance would the bee fly? So first off, looking at this, we need to figure out where our right triangle is. I mean, I've seen students do like this and then down here and across, and they kind of just like butcher this because they're not thinking of this room in 3 dimensions. They're thinking of it in like 2 dimensions, like a flat picture. The 3 dimensions we would want would be, well, first off, this line here is the distance the bee travels. This is our ultimate goal of the problem. I'm going to call it x. But to make this a right triangle, if you imagine a cube or a box or something, we can go down this corner, and then we connect our 2 endpoints across the floor. That, believe it or not, is a right triangle. That angle there is a right angle. It doesn't look like it in our picture because it's in 3 dimensions and it's kind of skewed for us a little bit. So, what sides of that do we know? Well, we know that the height of the room is 8. We do not know what this is, which makes us a problem because we can't do Pythagorean theorem with only one side that we know and 2 sides we don't know. So what do? Well, we can actually figure out how big this y is. So this is going to become a multi-step problem. We're going to do some math to figure out this. And once we know how big this is, we can do Pythagorean theorem with all 3 lengths to figure out our x. X is our final goal here. So how do we figure out this y? Well, the y here, this segment here, is a diagonal of the base. Well, what shape is the base of a rectangle? Or of a cube? I just said the answer. It's a rectangle. If I would draw that base, it's 15 feet this way, 12 feet that way. And we want that. That's our y. This is the same y as that picture. Y. 15 feet, 15 feet, 12 feet here, 12 feet here. This is a rectangle. We can find this. We know how. We did this in the previous lesson. This is just a Pythagorean theorem on a right triangle, finding the diagonal. So we do it. A squared plus b squared equals c squared. My hypotenuse is the missing side. So I'm going to plug in y for the c. That means the 12 and the 15 go into the a and the b. 12 squared plus 15 squared is 369 And now when we square root both sides to find out what because right now we have y squared is 369. When I square root and get just y equals square root second answer, that puts in the 369 in for the answer, I get 19.21. So I'm rounding to my hundredths place because the next digit over the thousandths place is bigger than a 5 or 5 or bigger. This rounds up to a 1. So that's the value I'm going to use in for y here. That's the same value I'm going to use in for y there. So first thing we did, we found this diagonal distance of the base so that now we know all three of these sides. In fact, I'm going to erase that y and I'm going to put in 19.21. So now we're going to do Pythagorean Theorem up here. So now we got a squared plus b squared equals c squared. My hypotenuse is the x. That's the side I don't know, so he goes in for the c. The 8 squared and the 19.21 squared go in for the other two sides. 8 squared plus 19.21 squared is, it's going to give us a decimal, 433.02. And then finally, when we square root both sides to make this x squared a plain old x, we're going to get square root that answer. And we got an answer of 20.81. So our final answer, the bee would fly a total of 20.81 feet. Now, if you did this problem on your own, you might have got an answer slightly different. There were multiple places in this problem where we rounded answers. We rounded this number here. When we did this math, I rounded this number here because it was actually 0.0241. I just kept 0.02, but actually when I did the math, I used all those digits. So you might have got a slightly different answer. You might have got like 20.80, 20.81, 20, maybe even a 20.9. Depending on how you rounded, your answer might be slightly different. Okay? So that's a problem that is worth maybe watching a second time. If not now, maybe later on when you're trying this problem on the homework or a very similar problem. This is a hard problem. It's multi-step. Understanding the process is what's important here. Okay, letter D says, a crow and a robin fly away from the same tree. A robin flies north for 3 miles and a crow flies south for 9 miles. Both birds turn to their left. That means the robin is heading west and the crow is heading east. And they fly for 6 more miles. How far are the birds from each other? Okay, so I want you to pause the video, draw your picture, and then hit play, and we'll look at the picture together, and then I'll give you more time to do the actual problem. All right, so here is my tree. Beautiful tree. It says, the robin flies north for 3 miles. I'll choose red for the robin. Robins are red, right? Flies north for 3 miles, and the crow flies south for 9 miles. Now, obviously my picture's not drawn to scale. This line is not 3 times bigger than that line. It's just something to get us kind of close. Both birds turn to the right, and turn to their left and fly for 6 more miles. So the robin is heading west, 6 miles. The crow is heading east, 6 miles. And the question is, well, how far are the birds away from each other? So that's the picture you should have drawn. Something close to it at least. So, check to make sure your picture looks good, and I want you to pause the video and see if you can continue on with the problem. Now, If you could not continue on with the problem, it might be because you're having trouble understanding how to find this distance. A very common mistake that I get is I get students who say, oh, if I Pythagorean theorem this 6 and 3, and then Pythagorean theorem this 9 and 6, I would take those two lengths and add them together. The problem is, if I do Pythagorean theorem with 6 and 3, I find this length, not that. And if I Pythagorean theorem the 9 and the 6, I would get this length. And the red plus the black is not the same thing as a straight line between these 2 points. It'll be approximately close, but it's not right on. So the trick here is, using this slanty, can we draw a right triangle that uses this slanty? How about straight down and straight over? Do we know how big those segments are? We do. We know that this is 12 this way and 12 this way. 9 plus 3 is 12. 6 plus 6 is 12. So now we have a right triangle. We know how big 2 of the 3 sides are. I'm only really looking at the blue now. And so now we can do Pythagorean theorem. And if you didn't do this yet, maybe you pause the video. But I'm going to do it now. So I know both my legs are 12 because the hypotenuse is the longest side. And that I'm going to use as x. That's going to be 144, and 144 is 288. When I square root both sides, I'm going to get, let's see, square root of 288 is 16.97. And I'm looking to, I took a second, I looked at my picture. Okay, 12, 12. This side should be bigger than both of those other two. It is. So that looks good. So I'm going to say my final answer is 16.97 miles. That's how far apart they are. The birds are 16.97 miles apart. A sofa is in the shape of an L. L. The long side of the sofa is 14 feet. If a man were to throw a pillow from the end of the short side, so that's here, to the end of the long side, here, it says, and the pillow traveled 17 feet, how long is the short side of the sofa? Oh, there we go. This really just took drawing and labeling the picture, okay? Because it's an L, we have a right angle down here. The long side is 14, the distance the pillow traveled is 17, and then we just go to town. A squared plus b squared equals c squared. My hypotenuse is the 17, so that's my c. The other two sides are just the other two sides. X equals x plus what? 14 squared is like 196, yeah. 17 squared, I don't know. 289. When I subtract 196 on both sides, x equals, is that 108? Nah. 289 minus 196 is 93. And so then I'm going to take the I say I'm going to take the square root to get rid of my squared, but I dropped my squared up here. Whoopsie. Make sure he comes along for the problem, because now I get x equals, the square root of 93 is 9.64. So the answer, the pillow, or the short side of the sofa, is 9.64 feet. And there we go. Okay, here's one for you. The diagonal measurement of a door is 91 inches, and the height of the door is 84 inches. What is the width of the door? And then also, what is the area of the door? So I want you to do this whole problem from start to finish because this problem has a fairly easy picture to draw. So pause the video, do the whole problem right now. When you're ready to continue, hit play, and we'll go through it together. So our picture looks like the diagonal distance is 91 inches. The height is 84 inches, and we do not know the width. Doors are indeed rectangles, which means that's a right angle, and that would be then the hypotenuse. So let's see. A squared plus b squared equals c squared. My hypotenuse is the 91. That goes in for c. The x and the 84 are the a and the b. There's no way I know what 84 squared is. Something big. 7,056. And then 91 squared is 8,281. When I subtract the 7,056 from both sides to, solve the equation, we get 1,225. That number looks familiar in my brain. I think that's going to give us a nice, pretty, perfect answer. When I square root that, I get 35. So this door is 35 inches wide. Answer 1. What is the width of the door? Check. It's 35 inches wide. What is the area of the door? So this is just background knowledge. To find the area of a rectangle, area equals length times width. Now that we know the width is 35, or the length is 35 and the width is 84, just, length times width is what I'm doing. Area equals 35 times by 84 is 2,940 inches squared. So area is 2,940 inches squared. And there we have it. The door is 35 inches wide and the area is 2,940 inches squared. Letter G. What is the side length of a square if the diagonal is 15 feet? So I want to know, that distance. How far is that? Things we know. We know this is a right angle because it's a square. Squares have right angles in the corners. But this seems very odd. So, here, a squared plus b squared equals c squared. I know that this 15 is my hypotenuse. This x, I guess, is one of my sides, but, what about this other side here? Well, because it's a square, they're the same. So do I just put in that? The answer is actually yeah, we can. And we can solve this equation. If I'm going to take x squared and add x squared, we can do this. What is 1x squared plus 1x squared? It is 2x squareds. Because they have the same variables, we can actually add these things together. 1x squared plus 1x squared is 2x squareds. And 15 squared is 225. Now to solve this equation, we've got a slight difference in how we're going to solve this. Instead of subtracting the thing away like we've done before, because this is a multiply, that's 2 times x squared, we're going to divide by 2 on both sides. 225 divided by 2 is 112.5. And now when we square root both sides, we get x equals square root the answer. So I did second answer just to put, it puts that number in for the answer. We get 10.6, oopsie, 1. It's actually 6.066, but I rounded to my nearest hundredth, so I stopped right there because the next digit over is a 6. That 0 rounds up to a 1. So 10.61. 10.61. And I can, well, yeah. So we found the lengths of the sides of this. And we can kind of prove this, that this squared plus this squared equals that squared. If I take this number, 10.6, actually, watch this. Clear. That answer squared plus the same answer squared. So I've got x squared plus x squared should equal 15 squared, which is 225, and it does. So a squared plus b squared does equal c squared. Okay, so this is a slight difference in how we've seen the problems. This only works because this is a square. And because these are the same length, when we put x's in for both pieces, we can actually combine that together and then continue solving the problem. So let's actually answer that question from the beginning of the lesson. A little warm-up. So how far would you have to go if you wanted to climb up the side of the pyramid? I want you to see if you can solve that one right now. Go ahead and pause the video and solve for x. How far is it up this diagonal here of the pyramid? Let's see. A squared plus b squared equals c squared. The hypotenuse, that's almost impossible to see. The hypotenuse is the x. I'm using this as my right triangle here. I know that the height is 455. And if you put 755 right here, you made a boo-boo. This piece from here to here is not 755. The whole base of the pyramid is 755. Do we want this whole thing? No, we only want from the midpoint to the end. So we're going to take that 755 and divide by 2. So this piece of the triangle is 377.5. This other piece would also be 377.5. That makes up the total of the base of the pyramid. So I'm going to plug in 377.5 in there, not 755. So check yourself to see if you made that mistake. Now, 455 squared plus 377.5 squared is big number, 349,531.25 equals x squared. I'm going to square both sides, and this is like the perfect example of why we have this answer button, because I can just hit square root, second, answer. I don't have to retype that whole thing back in. Equals 591.21. So the answer is 591.21 feet. If you wanted to climb right up the side of the pyramid, it would be 591.21 feet to go from there to there. Summary. Could you give 4 steps or so that could be used to help someone else solve any of these real world problems? What are some tips you would give? If somebody was doing a problem and they are confused, what's some advice you would give them? First thing I would say is draw a picture. I'm a big fan of drawing pictures. I think you should be as well. Because if you can get the picture on the paper, it kind of it frees up some extra mental space in your head. If you're just trying to keep track of every number and entire picture and everything in your head, it doesn't leave much room in your head for doing the calculations. If you put the pictures down on paper, it frees up your brain for calculations. Second thing, make sure you label the picture. Like put your side lengths, put the feet and the inches and everything. Make it a good picture. Make sure the hypotenuse gets plugged in for the c in your formula. And one thing I should probably throw back in here is find your right triangle. That's something some students don't do. Like in this problem, a lot of students would just take and use the random these two numbers and x to find their side, but they didn't look for their right triangle. The right triangle is here, here, here. That's not a whole 755. That's just a piece of it, half of it. So understanding that sometimes you have to divide numbers and stuff is helpful. Okay? So thank you so much for watching this lesson on Pythagorean Theorem word problems. Until next time, toodles.